Hey, it's Mr. Arwood again. Where we left off last time, we had talked about the slope-intercept form of a line, which gave us an equation we could graph from the slope and the y-intercept, and we graphed that. But we may not be given that information. So what I want to do now is I want to start off with the slope formula, which sometimes you will be given 2 points. And we'll call them x1, x1, y1, and x2, y2. Okay, so the formula is the change in y over change in x. So remember we call slope m. So we'll say y2 minus y1 over x2 minus x1. And the important thing here is to remember that x1, y1 is a point that goes over itself. And also x2, y2 is a point that goes over itself. So make sure you have those things lined up. So let's do an example. So let's just take the point 2, 3, and maybe 6, negative 2. So we shouldn't expect to get a nice number here. But before we actually jump in and see what that slope is, let's just assume we could graph these points. Let's come over to this graph and say 2, 3, and then 6, negative 2. So I have those 2 points. So I can look at that and actually calculate my slope. So why do I need a slope formula? Well, if these points were not on a nice fitting graph, it would be a lot of trouble to make a huge graph if we were in the very large x and y numbers, just to move our finger around and count them, or maybe they're fractions or decimals or roots, which are not easy to translate over into a definite finger move, which is usually what you do if you had a graph and you tried to do slope. So let's go ahead and go through. So what we have here is, we'll call the 2 x1, 3 y1. So that's our first point. 6 is x2, negative 2 is y2. So let's set up our formula. M equals negative 2 minus 3 over 6 minus 2. So that gives me negative 5 over 4. And let's come over here and double check that. Let's take our points and go from here. So we're going to go down 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4. Which gives me a slope of a slope of negative 5/4, because from one point to the next I went down 5 and over 4. Okay. So our formula has found the slope for us, and we could even come over here and try and connect these 2 points the best we can. Now we have the slope, we might do a better job, but we may be able to see, approximately what the graph looks like. But once again, if we're working with decimal points or roots or fractions, we may not know truly the y-intercept. So we may not be able to get the equation of the line very easily just from looking at the graph or playing around with the points. So let's introduce a new formula that if we don't start with slope-intercept, we can get to slope-intercept. Okay? So this formula will be called point slope formula. Okay, and just to start off and let you know a little bit about it, it can be used if you have 2 points, or if you have a point and a slope. Okay. So what's the formula look like? Well, it's y minus y1. So in here, y is part of the formula, where y1 is an actual point, equals m, which is our slope, x minus x1. So once again, the x and the y that stand alone are our line. The x1, y1 is a given point. So when you look at the formula and you kind of pick things out, you've got x1, y1, which is a point, and you've got m, which is a slope. Point, slope. Point, slope, which is the name of the formula. So I told you could use this if you have 2 points. Well, remember, just a moment ago, if we had 2 points, we could use the slope formula to get the slope. So we'll use the slope formula first. So if we kind of go back to what we had, we were given the points, and let's go back and look at them since I don't remember them. 2, 3, and 6, negative 2. Okay, 2, 3, and 6, negative 2. And we figured out that the slope from the slope formula was negative 5/4. Okay. So we had to find that slope first. So it doesn't matter which we use, but we can use the point 2, 3 and the slope negative 5/4. So we're going to plug these into the point slope formula. So if I do that, let's see here. If I do that, we're going to have y minus, in this case, 3, because this was y1 was 3 and x1 was 2. So y minus 3, the minus is part of the formula, equals negative 5/4, and that would be x minus 3. So let's clean that up because we want to get it to point slope, point slope for, slope-intercept form, because that's where we can graph it easily. So let's see here. We will use a distributive property. We have y minus 3 equals negative 5/4 x plus 5/4 times 3 would be 15/4. So what I need to do is get y by itself, so I'll add 3 to both sides. So now I'll have y equals negative 5/4 x. If I have 15/4 and I add 3/4 to it, which is really 12/4, I will have 27/4. Not something I was looking forward to, but it is a slope-intercept formula, and I know how to graph slope-intercept formula. So I know that the slope, give ourselves a little bit more room to work with, the slope is negative 5/4, and the y-intercept is 0.27. We could turn that into a decimal, but it's not necessary. It could be helpful. Well, let's see. Let me see if I can get a graph here for us to work with. Okay. Let's put this together and see if it works out. So we had 2 points. Let's try and put everything we know together. We had 2 points. We had 2, 3. And we had 6, negative 2. Okay. And that gives us a slope of negative 5/4, as we've already seen. 27/4. 27 divided by 4 is a little bit, well, it's almost 7. It's 6 3/4, so it's, here's 6, so a little bit up here. So if we can figure out how to draw a straight line, we would go down to these points. Once again, I'm trying to make a straight line with a stylus, but it looks something like that. So approximately what we had before, but now we can really make predictions because we've got a formula where we can plug in an x and get a y. So we don't have to rely on our graph if we want to plug in an x of 30, 40, 100, 200. We can plug it into the formula because now we've got that equation. Okay, so let that sink in, and let's give you a problem to try yourself. Okay, so let's just kind of write down what we have. We have the slope-intercept, which is our goal. Y equals mx plus b. We have the slope formula, which is m equals y2 minus y1 over x2 minus x1. And we have the point slope formula, which is y minus y1 equals m times x minus x1. Okay, and now let's give ourselves a little problem to work with. So we're going to say try it. And we're going to say given 2 points, let's make them 4, 3, and negative 2, 7. Find equation and graph. Okay, so let's hope we don't run out of time. Let's erase this part. So, pause the video, try this out, and then I'm going to work the solution. Okay. Alright, so you can check yourself here, and you can try and match up with what I've got. But let's see here. What we know is we were given 2 points, so we can use the slope formula. And we can label these as x1 is 4, y1 is 3, x2 is negative 2, and y2 is 7. So our slope formula is 7 minus 3 over negative 2 minus 4, which gives me a slope of 4 over negative 6. If you want to reduce that and rewrite it, we'd say negative 2/3. And then we can come down and we can use our point slope formula. Sorry. But we have our y1 and x1 identified, so y minus 3 equals negative 2/3 x minus 4. So we're going to clean that up, so we'll have x minus 3 equals negative 2/3 x plus 8/3. If you use the distributive property, we will add 3 to both sides. So when we do that, our slope-intercept form will look like y equals negative 2/3 x, which is our slope, and then 8/3 plus 3, which is 9/3, would be plus 17/3. So now we have the slope-intercept formula of our graph, where m equals negative 2/3 we already had, and the y-intercept is 0.17/3. So we have our formula in slope-intercept form. We have all the information we need. So let's go through and let's try and put our graph together off of that information. So let's get it here. Run out of time really quick. So the point we have is 17/3, which is a little bit less than 6. Yes, a little bit less than 6. And then negative 2/3. So down 2 over 3, down 2 over 3, down 2 over 3. And then we'll do our best to connect those. And then we can go back and check to see that we have the points. I didn't do a good job here, but we should have the points 4, 3, and negative 2, 7. So